Step one of the engineering design process is to define the problem. When defining the problem, you're going to figure out what is the challenge, what are the constraints, and how you could solve it.
The situation we were given was as follows. A snowstorm has hit and left a village completely inaccessible until the snow has melted. That could be days, and you and your team must deliver life-saving supplies to desperate people. To get the food, water, and medicine to the village, you will need to send an unmanned vehicle across the drifts with precious cargo attached. Your team may test their vehicles before the final runs are made, because to lose these supplies means the demise of this village. Should the cargo fall out during a practice run, it may be retrieved using a search party. If the cargo falls during your final run, however, it is considered a loss and the mission a failure, and failure is not an option. As with all engineering problems, we're given a set of constraints. In the real world, we'd have constraints like time and money and complexity of build, but in this classroom setting, we were given constraints such as the cargo can't be moved a certain direction, we're given a certain limit on the length and width of the car can only be propelled with a balloon or a rubber band. An important constraint to note is that we can only use the materials provided. The materials we were provided were 1 balloon, 1 plastic cup, 2 sheets of cardstock paper, 2 rubber bands, 2 small popsicle sticks, 1 large popsicle stick, 3 large straws, 1 pipe cleaner, 1 sheet of colored paper, 2 paper clips, and 2 index cards.
Step 2 is generating concepts, and when generating concepts, you're going to research and come up with ideas which you think will work, and after that, you'll make a design matrix and pick the best idea.
The third stage of the design process is to develop a solution. This is where you create your detailed sketches and justify your solution path. There's a lot of overlap between this step and generate concepts, so if your team ends up creating something new, they'd have to go back to their decision matrix and add it in and compare it with all their other different ideas. In this stage, our group went with the rubber band powered car with a paperclip in the axle to create tension and make the wheels move forward, along with a box on top to hold the cargo. The fourth stage of the engineering design process is to construct and test a prototype. This is where you plan your testing for the usability, durability, and performance of your prototype. This is also where you collect and analyze your data in a test report, which is similar to a lab report, and it shows the effectiveness of your solution. This will be used for step 5, evaluate your solution.
The test never almost works out the first time, which it didn't for us. So we had to fix a few things. We had to fix the tab for the paperclip and fix it and make a hole in the popsicle stick in order to make it work. And we had to go with a thicker rubber band than the thinner one in order to make it work.
It's important to note that during this step, if your solution just doesn't seem to work, you might have to go back to step 2 and 3 to create new sketches or just an entirely new solution altogether. The fifth step of the engineering design process is to evaluate your solution. This is where you evaluate the effectiveness of what you made and reflect on the design. If necessary, you would need to optimize or redesign, like go back and go to step 2 and 3. And this is where you also get project recommendations, which is just drawing conclusions from the data and answering the question, does the solution really solve the problem? The final step to the engineering design process is to present your solution. This is where you show off your project in the form of a presentation or a video or a research paper. This is where you're selling your product to buyers and that sort of thing. Thanks for watching. Now go out there and be an engineer.